So a lot of beginning composers will ask the question, why learn harmony? Or sometimes even, why learn theory at all? Does theory dictate what a composer does? Well, no, theory does not dictate what composers do, but theory is a description of what has happened in the past. We all have the benefit of hindsight. We can look at a composer like Bach or Beethoven, analyze their music, and eventually gain insight into the kinds of thought processes that may have went into their composing. Now, will these be exactly what the composer was thinking about? No, it probably won't be, but more or less, it will be close to what they were thinking about, and it'll give you a new way of thinking about and creating something new. So we learn theory and harmony in order to create new ways of thinking about the elements of music and how we can use them to compose new and interesting pieces. As Walter Piston says in his book Harmony, the person gifted for creative musical composition is taking a serious risk in assuming that his genius is great enough to get along without a deep knowledge of the common practice of composers. So with that being said, what is harmony? Well, harmony is sound created by the simultaneous use of notes. When you play more than one note at a time, it creates a harmony. And this harmony could be consonant, like a major triad, or it could be dissonant, like a tone cluster. The study of harmony is the study of how notes coming together make different kinds of chords and how those chords move from one to another. So where should we begin with all this? Well, let's start off by talking about intervals. Now, in Melody Part 1, we talked a little bit about intervals. During that lesson, we mainly talked about one interval, the third. The reason we talked about the third is because it's what makes up the triads in a diatonic scale. The third is only one of many intervals that a composer should be aware of, though, and familiar with. First, a clear definition. An interval is the distance between two notes. This distance can either be horizontal, which is a melodic interval, or it can be vertical, which is a harmonic interval, where the notes are played simultaneously. And we classify intervals with two designations. The first designation is the size of the interval. This is calculated based on the number of letter names that span two notes. Let me illustrate. Let's say we are looking at the C major scale. If we wanted to find the size of the interval between C and G, then we would count how many notes that interval encompasses. So count with me. C equals 1, 2 for D, 3 for E, F is 4, and G is 5. So C to G is a fifth. And this works for any intervals in any scale. D to F, D is 1, E is 2, F is 3. That's a third. F to B, F is 1, G is 2, A is 3, and B is 4. That's a fourth. So we've got it. And when you get down to it, there are basically 8 intervals within the scale. An interval of 1 is called a unison. Obviously, it's a little hard for me to play the same note twice at the same time with one keyboard. But either way, if you're working within a major or minor scale without any accidentals, then this is the same note. C to C is a unison. So an interval of 2 is called a second, in this case C to D. An interval of 3 is called a third, and that's C to E. An interval of 4 is called a fourth, that's C to F. An interval of 5 is called a fifth, C to G. An interval of 6 is called a sixth, and that's C to A. And then an interval of 7 is called a seventh, C to B. And then an interval of 8 is called an octave, and that's C to C. Now technically at 8 and beyond, the intervals repeat themselves, and depending on how you are analyzing your music, you can either call them by their lower number or their actual interval. So for instance, a second up an octave becomes a ninth. A third up an octave becomes a tenth. and so on. I recommend that you learn all of the intervals and their equivalents in all keys for 2 octaves. So you need to know that, for instance, a 15th is 2 octaves. So I said earlier there are 2 ways of classifying an interval. Size is what we just went over, and the other one is quality. Now every interval has a quality, and this quality is really what dictates how that interval sounds. There are 5 interval qualities, and they are major, minor, perfect, augmented, or diminished. You'll see some of these, they're kind of relative in how they sound. So now at this point, it's hard to separate the quality from the size. So I'll go over what each of these qualities mean along with the sizes that they're associated with. Now if we look at basic sizes of intervals, we can classify them into 2 main groups. Group 1 has unisons, fourths, fifths, and octaves. And then group 2 contains seconds, thirds, sixths, and sevenths. So let's look at group 1 first. Group 1, we have what are called perfect intervals. In both major and minor scales, if you were to put them up, we find that the interval is the same in both scales. So in C major, you got a unison, a perfect fourth, a perfect fifth, and an octave. And in C minor, same thing. Now these intervals, for the most part, are called perfect because in early music, they were considered perfect consonances. Think of when we talked about organum in Melody Part 1, when you only had a second line that added music that was a perfect fifth away. Now I won't go into detail about how the perfect fourth can be considered a dissonance and counterpoint, because for right now, it's not really that important. I'm just saying this so I don't get a bunch of naysayers trying to point out that every little mistake I make, and it doesn't really change the fact that the interval of a perfect fourth is still a perfect interval. I'm not talking about consonance or dissonance right now. Now, one way to remember it is the perfect intervals, they've got this really kind of open sound. They don't say really anything about the tonality of the piece that you're in. So, either way, these intervals are never considered major or minor. They're just perfect. But there is a way to modify them, and that is where the augmented and diminished qualities come in. If you were to take an interval, let's say a perfect fifth, and then you would raise that top note by 1/2 step, you have an augmented fifth. So basically, to augment an interval is to raise it by 1/2 step, or widen it by 1/2 step. And you would label this as A5. And the opposite direction of this is to lower that perfect fifth by 1/2 step. You get the diminished fifth. So any perfect interval, including unisons, octaves, fourths, and fifths, can be either diminished or augmented. And yes, in theory, you can have a diminished unison, but in reality, you won't see it written like that. You're probably more than likely just going to see the major seventh written below it. But, you know, depending on what kind of music you're writing and what the score is doing, you may need to put a diminished unison. So to summarize group 1, you have unisons, fourths, fifths, and octaves. As a plain interval in the major or minor scale, these are all considered perfect. And then you can modify them by either going up or down by 1/2 step to create augmented intervals or diminished intervals. So let's look at group 2. Group 2 contains the other interval sizes in the scale, and it is within this group that you can see the differences with major and minor scales. The easiest way to remember this is if the upper tone of an interval belongs to the major scale of the bottom note, then it's a major interval. If the upper tone belongs to the natural minor scale of the bottom note, then it's a minor interval. So in C major, if you're looking at the intervals from C, you're going to have a major second, a major third, a major sixth, and a major seventh. In C minor, you would have a minor third, a minor sixth, and a minor 7th. The one exception is the second, which is a major interval in both major and minor scales. Now this is relatively easy for C major, but if you look at another more complicated interval, you'll see it becomes a little bit trickier. So if we were to look at E to C sharp, well, if we count the notes from E to C sharp, we get 6. So E, F, G, A, B, C. And I didn't add any key signatures there for a reason so that I'm not jumping ahead of myself. And then let's look at E. If we were to put the key signature of E minor, we would see that there's only one sharp. It's the same as G major. So in fact, there's no C sharp in E minor. So let's put the key of E major. There are 4 sharps in E major, including the C sharp, so that means that the C, being a 6, is a major 6 because it's part of the E major scale. So I hope this trick helps a little bit. It is a good way to figure out intervals. Obviously, the second interval is a little bit different, but you're only a second away, so it's actually a relatively easy interval to figure out. Now, as well as having major and minor intervals in the group, or in group 2, you can have augmented and diminished as well. The augmented interval is always 1/2 step above the major interval, and the diminished interval is always 1/2 step below the minor interval. Now, this can be a little bit confusing because we're going to start to move into enharmonics territory. For instance, if we're looking at a bottom note of C, we can either have a major third or we can have a minor third. Now, 1/2 step above the major third, we get an augmented third, which is an E sharp. And then below the minor third, we have a diminished third, which is an E double flat. Now, for some people, this would seem to be excessive. Why would I write an E sharp when I could just write an F? Or why would I write an E double flat when I could just write a D? Well, there are many reasons in a given composition why you would want to write an E sharp. For instance, if you are in E major and you are moving up from E up to F sharp chromatically, you could write E, F natural, and then an F sharp, but that makes a lot of accidentals. Or you could just write E, E sharp, and then the F sharp is naturally there because of the key signature. It becomes a much cleaner score. And that doesn't seem that bad here, but with passage like this, it can make it much more readable. Now, in the top example, you have only 6 accidentals versus 9 on the bottom example. Plus, you follow the convention of raising the pitch as you are going up instead of lowering it, like when you are moving from E to F natural. But the other reason is because you want your music to be clear as to the intent. If you write an F over a C, someone will look at that and think you meant to write a perfect fourth. If you write an E sharp, they will know that you want an augmented third. The difference may be mental, unless you're using some other kind of tuning system besides equal temperament, but the mental aspect of a composition is very important, both for players and composers. So let's recap. You have, in group 2, seconds, thirds, sixths, and sevenths. And each of these can be major, minor, augmented, or diminished. The easiest way to figure out if it's a major or minor interval is to imagine if the top note fits within the bottom note's major scale or minor scale. Now, moving beyond the octave, you get what are called compound intervals. And as I stated earlier, I won't really go into depth on them too much. I do recommend just learning them cold, as with everything else. The main reason why you don't have to worry about learning them as different intervals is because of something called octave equivalence. Now basically, because we have an equal temperament tuning system, each octave effectively sounds the same, just higher or lower. This means that effectively a third sounds like a tenth, and a sixth sounds like a 13th. Now, to get the compound interval size, all you have to do is just add 7 to the lower interval. So a second plus 7 becomes a ninth, a third plus 7 becomes a 10th, a fourth plus 7 becomes an 11th, and so on. And most of the time, you're only going to see it labeled up to the 15th. And even then, the 15th is usually just written as 15 VA to designate that it's supposed to be 2 octaves up. Now, if you're into jazz and you're learning or have learned jazz harmony, then you'll probably see the 9th, the 11th, and the 13th used quite a bit in jazz harmony. And the reason is because those chord tones tend to be modified in some way. So you're not just, I mean, you could just get a normal 9th chord. That's a C major 9. Let me play that down. But a lot of times you'll have, a sharp 9 and then it'll be a dominant 7th chord with a sharp 9. Or even a flat 9. Or both. Or maybe a flat 13. So I wouldn't worry too much about that in traditional classical theory. I mean, you're always free to use those in your own composing as much as you want. But when we're sticking to the basics, you really only need to know about them, but you don't have to worry about them too much. Now let's say that you're writing a part that has a major third interval above C. If you wanted to put the top interval below C, so basically put the E below C, you would drop that E by 1 octave. But when you do this, the interval is no longer a major interval. It's a minor interval. Now remember back to our experiment with E. E to C is a minor 6th because the C is in the E minor scale. Now what this shows is that when you invert an interval, it changes the quality of that interval and its size. So a major interval becomes a minor interval. So, here we've got a major third, becomes a minor 6th. A minor interval becomes a major interval, so here's a minor third, becomes a major 6th. A perfect interval will actually stay a perfect interval, so if we have a perfect 5th, it becomes a perfect 4th. Augmented intervals become diminished intervals. This is an augmented 6th, an augmented 5th becomes a diminished 4th. And then diminished intervals become augmented. So here is a diminished 5th, and it becomes an augmented 4th. And this makes it pretty easy to find the quality of an inversion. But how do we find the size? Well, that too is pretty easy. Just subtract the first interval from 9. So in C major, if we invert the minor 6, we know that we're going to get a major interval. And 9 minus 6 is 3, so now we know we have a major third. If we have a perfect 4th and invert it, it stays perfect, and 9 minus 4 is 5, so we get a perfect 5th. And if we have an augmented 5th, G sharp, we invert it, and we get to G sharp below C. 9 minus 5 is 4. We know that it's a 4th, and we know augmented intervals become diminished intervals, so now we have a diminished 4th. You could even check this by looking at a G sharp scale, either major or minor, and we'll pick minor because G sharp major is pretty crazy looking. If you look at G sharp to C sharp, it's normally a perfect 4th, but because the C is natural, it's a diminished 4th. Now, I highly recommend practicing and memorizing your intervals. That's why exercise 1 is all about the intervals. I want you to practice and get comfortable with your intervals, especially basic perfect, major, and minor intervals within each key. It will pay off in the long run.